Hello dear friends, welcome to Humble Mag Academy. In this video guys, we shall be looking at how to evaluate the integral of flow functions guys, namely the integral going from 1 to 3 of the flow function of x plus x squared dx. So guys, stay tuned and watch the entire video so that you're going to understand the entire concept involved. So guys, if you're new to this channel, don't forget to hit that subscribe button looking at you guys, because that is the only way in which I'm going to help you to pass your exams with very good grades. I can only do so once you subscribe to my channel guys. Let's get started. That's great friends. The question is saying that if this symbol of x represents the greatest integer function less than or equal to x, then the definite integral going from 1 to 3 of the flow function of x plus x squared dx is okay. So guys, the flow function of x is not a function that is very common to the mathematics syllabus. That is the common GC mathematics syllabus. It is not so common, but it is very common for those who are taking further mathematics. So I want us to observe how the flow function of a number looks like, namely guys the flow function of x. Let's look at some exercises. Let's assume that I want you guys to get a flow of 1.2. okay, now guys, just from the definition of the flow function of x, it is simply defined as what guys? The greatest integer function less than or equal to x. So guys, ask yourself, which is the closest whole number that is less than or equal to 1.2? Guys, that smallest number that is less than or equal to 1.2 is simply what guys? 1, right? Wait, it is simply 1. Now guys, what is the flow of 2? Ask yourself guys, which is that integer which is less than or equal to 2? It is 2 itself, right? Wait, so it is 2. Now guys, what is the flow of negative 2.7? Ask yourself again, which is that whole number which is less than or equal to which is either less than or equal to negative 2.7? Great guys, it is what? It is negative 3. Great. What is the flow of negative 1 guys? As well, it is still negative 1. Great. So guys, now that we have some clear understanding about a flow function, let's now go ahead now to evaluate our integral. So we'll be looking at the definite integral going from 1 to 3 of the flow function of x plus x squared dx. So guys, according to our properties of definite integrals or of integrals itself, keep in mind that the integral function is a linear function. It therefore means that we can simply get this done by simply integrating the sum of each of these functions. So we are going to have the integral going from 1 to 3 of the flow function of x dx plus the integral going from 1 to 3 of x squared dx. We can evaluate this conveniently, right? The integral of x squared dx is very cheap. So we are going to do the power rule. That is, we'll add 1 to the power and divide by the new power. We are going to have 1/3 x cubed. Alright. The limits of integration guys are from 1 to 3. So guys, I have a video where I taught students how to get the integral of functions like this. Make sure you check out the link in the description below for that video. Make sure you watch it, because on the day of the concours guys, you're going to have so many questions that are going to be calculus based, namely differentiation and integration. Great. So guys, if we evaluate this so well, we are going to have the integral going from 1 to 3 of the flow function of x dx. When we put the limits of integrations and subtract, we are going to have 26/3. Okay. So guys, we have succeeded now in getting the integral going from 1 to 3 of x squared dx, right? Let's now get the integral now from 1 to 3 of the flow function of x dx. So guys, by so doing, let's define some function y equal to the flow function of x. Let's establish a table guys, because the easiest way to do this guys, the easiest way that you can see things happening by yourself is to use the graph. Okay, let's try to graph the flow function of x in the interval from 1 to 3. Okay, let's now say that when our x is 1 guys, what is the flow function of 1 guys? It is simply 1. Okay, the flow function of a negative number guys, or the flow of a negative of a whole number, sorry, the flow of a whole number guys is simply that whole number itself, irrespective of the fact that it is negative or positive. It is that number itself. So guys,
when our x becomes, let's just take some small number like, let's say 1.5. Well, what is the flow of 1.5, guys? It is still 1, right? Because 1 is the smallest integer that is less than 1.5 or equal to 1.5. That's it, guys. What then happens now when our x is 2, guys? What is the flow function? What is the flow of 2? What's the flow of a whole number, guys? Still that whole number. So we are still going to have 2. Then, friends, what is the flow of 2.5 when x is 2.5? It is simply what, guys? Still 2, right? What then is the flow of 3, guys? It is still 3. Great. Okay, now let's look at the graph. Let's see, we have our y-axis, we have the x-axis. Let's call it the x-axis. Great. This is the point where we have 0, guys. Let's label our horizontal axis. We're going to have 1, 2, and 3. We end at 3 since we have to get the integral from 1 to 3. Let's label the vertical axis. We're going to have 1, 2, and 3. Great. So now, guys, let's try to see if we can plot these points on our curve, on our graph. Keep in mind, friends, keep in mind solely that the flow function has what, guys? Has jump discontinuities. Okay, it has some jumped properties. We shall see that. All right. What is when our x is 1, guys? What is the flow function of 1? It is still 1, right? So when x is 1, we still have our y to be 1. Great. All right. What will happen now when x is 1.5? What is the flow function of 1.5, guys? It is still 1, right? So we are still on this axis. Then, guys, when x is slightly less than 1, we are still going to have what? Still 1, right? It therefore means that here we are going to have an open circle at this point. Okay, an open circle, because when our x is 1.5, our y is still 1. So there is some jump. Okay, when x now becomes 2, our y is equal to what? Still 2, right? So it's still 2. So at the left, guys, at this left diagonals, we are going to have what? Shaded circles. Okay, we're going to have closed circles. So when our x now becomes 2.5, what's the flow function of 2.5, guys? It is still 2, right? So all at this point, guys, we're going to have open circles. Likewise, over here we have a closed circle. So this is how it looks like, guys. Like I said, it has some jumps. Okay, it has some jump discontinuities. Great. So if we connect all of these points, guys, if we connect, we are going to have like this. We connect the points, connect like this. Great, guys. That is it. So, guys, this is simply the flow function of x in the interval from 1 to 3. Great, guys. Great. Sorry for that noise, friends. All right. Now, all we need to do is simply to get the area of these our rectangles. Okay, that is going to give us this integral. Let's try to get the area of these our rectangles. By so doing, the area of the first rectangle, guys, what is the width? The width of this rectangle is what? 1, right? And the height, the width is 1, and the length is still what, guys? Still 1. That is 2 minus 1, which gives us 1. Then now, if you look at the second rectangle now, the length is what, guys? Is 2, and the width is 1. So we are going to have 2, because the area of a rectangle is simply length times width. Here, 1 times 1 is 1, 2 times 1 is simply 2. So it therefore means that, guys, the integral of this our flow function from 1 to 3 is simply going to be, we are going to sum these our individual rectangles. So we are definitely going to have 1 plus 2, which gives us 3. That therefore implies, guys, the integral of this our entire function is simply going to be the value for the integral of the flow function of x, which is simply what? 3 plus that of x squared, which we have here to be 26 over 3, right? If you simplify, we are going to have our answer to be 35 over 3. Great. So, guys, this is the answer. This is how we could handle that particular problem. So, guys, thank you guys for watching the video, guys. Make sure you subscribe to the channel if you want to have more great content from us. Feel free to leave your worries in the comment section down below, guys. I'll get back to you as soon as possible. Make sure you go to the video description section, guys, to find the link to join our WhatsApp group for proper preparation, guys, because it prevents poor performance. Have a blessed day, friends.